Hello everyone. In this video we're going to be solving a very interesting exponential equation. We have 1 to the power x equals -1, and we're going to be solving for x values. Before we start solving this problem, I just want you to think about it a little bit. Can we find an x value for which this is true? I believe at some point there was a comment made by one of my viewers, said something like there is no power that would turn a positive number into a negative number. So that's basically what we're looking for here. But before we start with the solution, I want to show you a couple things. First of which is a graph. Obviously, a lot of times when we're solving equations, especially exponential equations, we want to look at the graph either at the beginning or at the end, because the graph gives us an idea, about intersection points. So when you graph these two functions, y equals 1 to the power x and y equals -1, or f of x and g of x, whatever, then you're looking for intersection points. And here we go. In Desmos, it's like, what? There is no intersection point. Why? Because 1 to the power x equals 1, and -1 and 1, those are horizontal lines. They never intersect. Well, they intersect at infinity, but that's not a number. We can't reach there, so on and so forth. So there's no intersection point in the real world. Now, when we consult one of the most important resources that we can use to check our work or just to find the answer, Wolfram Alpha, then it tells us the result is false. So Wolfram Alpha is saying this is impossible. But let's go ahead and explore a little further. So here's what we're going to do. We notice that there's no intersection point, which tells us that there are no real solutions. What's that supposed to mean? It means there might be some solutions that are not real. So let's rewrite the equation. 1 to the power x equals -1. And we're trying to solve for x. So let's go ahead and do the following. Make a coordinate plane system for our complex number. This is going to be the real axis, and this is going to be our imaginary axis. In general, if you have a number z like a plus bi, you're basically going to go a units on the real and b units on the complex or imaginary, whatever. And then that's going to be a point. And that point or dot is going to be representing our number z. And this number obviously is some distance away from 0. And that distance is going to give us the absolute value of z, or what we call modulus, or we usually use r for that. Okay? And how do you find r? From Pythagorean theorem. If this is a and this is b, by the way, I just assumed for simplicity's sake a and b are positive, but they don't have to be. This is always true. The absolute value of z, which is r, is going to be the square root of a squared plus b squared from Pythagorean theorem, because this is a right triangle, so on and so forth. Make sense? So by using this idea, we can basically graph both of these numbers, 1 and -1, and write them as complex numbers. Let's start with 1. How do you find 1? And by the way, I forgot to say, there's an angle that's formed, which is theta, which allows us to write this number, z, as a polar form. So we can write this as r times, I should probably write it here where we have more room. So let's go ahead and write z as r times cosine theta plus I sine theta. I'm not going to go into the details of this, but you can also write this as r times e to the power I theta. This is a more compact form thanks to Euler, where we can use to write complex numbers. So we're going to find the theta and the r, but r is the absolute value of 1, which is 1, and absolute value of -1 is also 1. So r is 1 in both cases. But the first one, the angle is formed here because we're talking about 1 plus 0i, right? So that is 1 plus 0i, so the angle is 0. And what about the -1? It is actually going to be right here, and the angle is going to be pi for that. So how do you express 0? So you can basically write the angle theta as 0, but don't forget, you could also add multiples of 2 pi. So because it's just going to give you more rotations. Okay? And if we wanted to write, this is basically are for 1, and for -1 it's going to be pi. All right, so let's go ahead and do it. 1 will be replaced with e to the power 2k pi I. This is going to be 1, and we're going to raise it to the power x. And then the -1 is going to be replaced with e to the power. Now, how do you write this angle, right? The angle for -1 is pi, so you can write it as e to the power pi I, but you can also add basically multiples of 2 pi to this. So you can kind of write it like this: pi plus 2n pi, and then multiply the whole thing by I. Because what you multiply by I is always the angle, which is theta. Make sense? So we can kind of simplify this a little bit and write it as 2n plus 1 multiplied by pi multiplied by I. So we can kind of write this as e to the power 2n plus 1 pi I. So we get this equation. So everything that we try to do here was to obtain this equation. Now let's go ahead and solve for x, but stay with me because we're going to do something interesting here. Now, if you distribute the x or just multiply, e to the power 2k pi ix equals e to the power 2n plus 1 pi I. Obviously, pi I cancels out because they're not zeros, right? Pi I cancels out. And we can end up, since the bases are equal, we can basically say the exponents are equal, and we get the following equation, which is super duper simple, by the way. 2kx equals 2n plus 1. And I don't need parentheses anymore. Now notice that k and n are integers, and they don't have to be the same numbers. Let's go ahead and solve for x. Fairly easy. X can be written as 2n plus 1 divided by 2k. So what does this represent? 2n plus 1 is an odd integer. 2k is an even integer. So you kind of have like an odd over even situation as your power, which is kind of interesting. For example, if n is 1 and k is 1, then we're going to get x equals 3/2. And then let's go ahead and plug it into our equation and see what happens. 1 to the power x equals -1. Replace x with 3/2. You get 1 to the power 3/2 equals -1. And you're not thinking like, how is this possible? Is this going to work if I square both sides, right? Let's go ahead and square both sides. We get I cubed equals 2. I mean, not 2, 1. It just didn't work. Okay, so this is not the real world. So things are a little different here. So what does that number represent? To get a better idea, let me go ahead and show you another value that we can derive from here. What happens if n is equal to 0 and k is equal to 1? Then we get x equals 1/2. And let's go ahead and plug it in. 1 to the power 1/2 equals -1. And yes, this is true, because if you think about it as the complex square root, then 1 has 2 square roots, 2 complex roots, and those are 1 and -1, right? When you write square root of 1 as a complex number, there are 2 answers. This is basically multi-valued. And obviously our solution is also multi-valued, because when you change the values of n and k, you get different values. Make sense? Okay. That brings us to the end of this video. I want to thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.